Thanks, Laura. Thank you very much. Thank you. Everyone hear me okay?
Yes.
Good stuff, good stuff. A bit closer. I mustn't forget to do this rather than that. Okay. Chairman, office bearers of 973 chapter of EAA and guests, good morning. It's a pleasure to be here and it's nice to see such a good turnout. My talk today is as defined on that top line, and there are two words on that slide that I want to just spend a little bit of time on. The first one is development. It's a huge task to cover in one simple talk today. So I've cherry-picked quite a few highlights, I guess, just to give you an idea of where the whole program started, what was involved, what the tentacles were into other programs that were running at the same time, of the same level and intensity in South Africa. So that'll be some idea that I'll give you there. And the second one is talk. It's a talk, it's not a lecture. So please, if you have any questions at any time, just stick up your hand and we'll address the question then and there, rather than we'll save them all for the end where you may have forgotten. I see all the greybeards might have forgotten. So we'll give them a chance to do that early. Thanks to TC for initiating this. Thank you, Laura, for pointing me in the right direction. I nearly got lost getting here. Stuart, thank you for setting it up. I'm also very pleased to see an old colleague of mine, well, an ex-colleague, let's put it that way. Clement sitting up here. Is the volume too low?
Yeah.
Okay. Clement and I worked together quite a lot, various interfaces during the program, and I'm sure Clement will be able to help me answer some questions and also point out where I might have said something that's wrong. Okay. So, where do we start? Thanks, Stuart. Next one, please. Okay, just go back to the blank one. Blank. Yeah, just that.
Go back.
Okay, we're ready for a second takeoff. That is the Rooivalk, the Rock Falcon, and the name was very aptly chosen for the aeroplane, for the helicopter, based on the habits of this particular bird. It's a hunter, it's a hoverer, it has extremely acute eyesight, it hovers very well, it dives very well, it attacks very well, it's very agile, and it has a splendid sighting system. If you look at any videos of this bird in its hunting mode, you'll see it keeps its head perfectly still. And this kind of analogy, just bear it in mind as we walk through the presentation. Thanks, Stuart. Laura said I would give you a brief summary. Here it is. So I matriculated in 1966. I did pilot's training in 1967 at the Notta. Wings in 68. I opted to go for helicopters, which I've never regretted. I would not be standing here had I not made that turn in my career. I did 3 bush tours in the Alouettes, up in Angola 68 to 70. I then spent some time on super freelance at Swartkop, 70 to 73. And as happens to all Air Force pilots, you go back to doing instruction. So I did a couple of years of instruction back at CFS Denotta on Harvard, 73, 75. Production test flying of new Alouettes and Pumas. For those of you who don't know, there was quite a flow of new helicopters, Alouettes and Pumas from France, which the world didn't know too much about. And they were assembled and tested at Snake Valley at Swartkop, and that was my primary function because of my interest in test flying that I'd asked to get onto. I was then very lucky to have been chosen to go to test pilot training at Boscombe Down in 1977. I was then at TFDC, the Test Flight and Development Centre at Waterkloof, from 78 to 89. I then went to Atlas Aircraft Corporation when the Rooivalk program was in its infancy. I transferred to Atlas Aircraft, and then 2005 I left and joined Paramount, did a lot of work on Mi-24, Mi-171, EC-135 weapons upgrades and that sort of thing. And then I retired, and here I am. Thanks, Stu. That's just some badge that I'm very proud of. At the bottom, the logo says learn to test, test to learn, and that's the function. That's what was taught at Empire Test Pilot School. You learn how to test, and then you go into work and you test to learn, as we did during the Rooivalk program. Stu? All right. I think I just need to step back a little bit and emphasize a bit more about the development side. It was not an isolated program, huge program, but it was done in conjunction with another set of Army, primarily, programs, such as the Rooivalk and other platforms which ran almost in parallel. And that gives you an idea of the scale of military development that happened during the 80s and 90s. It was enormous. Clement and I were talking about just this before the talk, and just kind of marveling at what actually happened during those years. The depth and breadth of engineering expertise in the country was enormous. Okay, having said that then, the threat in the 60s and onwards was determined to be modern ground and airborne equipment supplied and operated by the Soviet Union and its proxies in Angola. For those of you who remember those days, that was the threat, the Rooi Gevaar. It was coming down from Angola, and they were equipped with very modern pieces of kit, which posed a real threat. So the decisions were made to build equipment to counter the threat. The threats included artillery, tanks, APCs, armored personnel carriers, radar systems, ground-to-air missiles, fighter aircraft, and attack helicopters. That, very broadly speaking, and a very important one right at the bottom, day and night capabilities were assumed to exist. In other words, we had to prepare this machine to fight day and night in the African environment. Okay, so within the wide determination of requirements, as I mentioned, related to the helicopter, the platform, at that stage they didn't even know whether it's going to be a helicopter or not, but a platform must exploit the low-level environments to be below or remain below radar and visual detection envelopes, and to be able to use ground features as cover. The next slide will illustrate this a little bit more clearly. Sorry, Stu. Thank you. And as I mentioned, must operate 24/7 in the environmental conditions. So when those were all put into the pot in the macro level, it became clear that the only platform that could actually operate in this environment was a helicopter. It's too low for fast fixed-wing aircraft. Helicopter has an advantage, as does the Rock Falcon, the Rooivalk, of being able to use ground features, hover, and be quite agile. So that we can go to the next one. Thanks, Stu. That Clement will remember that diagram, I'm sure. Okay. Please remember, I should have said it earlier, that we're talking about what happened in the 80s, what the systems were in the 80s, what the threats were. Today, as you all know, things have changed dramatically. This would never have been floated with the expertise and technical things like drones and so on that exist today. So we're talking about a development to counter a threat which existed in the 80s, and without the threat of drones and all that sort of thing, which would be a serious problem for low-flying helicopters. Just keep that in mind. So, did I switch something off? 1, 2. Let me carry on if you can hear me. Yeah? You okay at the back?
Talk without it, yeah.
Sorry?
It sounds better when you talk without it. I think it's useless.
Okay. I hope I talk more sense without it. Don't worry, Stu. If everyone can hear me, I'll just up the volume a bit. Don't worry, don't fret. Okay, so assuming then that the enemy installation is there, and it could be anything, it could be whatever target you can imagine controlled by the enemy that is needed to be neutralized. They would protect their infrastructure by a whole, wait for that noise to go, by a lot of protective devices, radar, high to medium altitude air defense weapons coupled to radar, up to 20,000 foot. Then as we got further out, low, medium altitude weapons, short range air defense weapons, and then man-pads, portable ground-to-air missiles. So you can see from this that there was what we called an operational window, which forced you lower and lower and lower, and slower, because flying low you need to fly slow. Oh, we're back. Can you hear me now with the reduced 1, 2? 1, 2. Okay. So lower and slower, and that really defined the platform. It was a bit early to define it in that way, but it defined a helicopter platform, just logically thinking about it.
Excuse me, just hold the mic close to your mouth.
If we can just turn the volume up if you don't mind. Can you hear your voice above the speaker? Put the speaker on the table. Yeah.
It's like a headset, you must be able to kiss the microphone.
Keep talking to
1, 2, 1, 2. Is that too loud?
That's better.
Okay. Stu, you're going to be exhausted after this. Thank you. And you can hit the button, thank you. So, just to give it a little bit more of a pretty picture, that would be the target area. This would be your forward operating base. And your entry to that would be a low-level cruise, low to keep out of sight of radars and so on. And then you'd go into what we call a nap of the earth flight route, keeping as low as possible, below 50 foot in most cases, using terrain masking to keep below being seen. Then position, probably attacking from the hover at the various targets you have, and then obviously exit the same way to land. So that gives you an idea of why a helicopter was needed to do this job. Stu? I talked about other major projects that were ongoing at the same time, parallel, huge. That machine, Rooivalk, okay? There was much commonality in the Army thinking tactics-wise of how these two systems would operate in tandem. That's another subject altogether. Just gives you an idea of the size and scale of the operations that led to the development of these two machines in a fairly short period, Clement, 10 years or so, I guess.
Yeah, I got started in the early 90s.
Yeah, we'll get to the early bits a little later. The concept of Rooivalk as it started being defined as the machine you see there came quite a number of years after the initial thinking had taken place. Stu? There's another one with the Rattle and the Rooivalk. Here's a good commonality thing. Who can see what would be common in those two? I'm sure you can, Clement. The gun. Yeah, so common gun, cannon, 20mm f2 cannon. It was exactly the same on the Rooivalk as on there. There's commonality in spares, supplies in the field, and that sort of thing. That was the scope of the thinking that actually took place in those days. Quite interesting. Stu? Okay, so having got to the stage where we needed a helicopter, when I use we, it's not the small Denell team or Atlas Aviation team that existed in those days. It was the global team. The we included the Air Force, the Army, Arms Corps, and the whole lot. So the we encompasses a whole lot of things. It's not just a small team that I'm talking about today. So, next click. All right. There was a lot of serendipity involved in what we were able to use. And it just happened to be that we had a nice platform available to us, which did give us a larger helicopter, and it's all to do with rotor performance, dynamics, and so on. Generally speaking, I think it applies similarly to fixed-wing aircraft. The larger rotor diameter, a little more payload and range one can achieve. So a larger helicopter was the initial thinking. Stu? We were limited in the choice since timescales and engineering challenges precluded the development of an entirely new platform. There's an old adage in aviation, I'm sure you guys know all about it. The one I remember is never try to develop a new airframe and a new engine, for example, in tandem. It's going to end badly. So we knew early on, Clement, I guess, that to develop a brand new helicopter, rotor head, blades, gearbox, and all those very difficult technical challenges was probably out the question. Stu? So fortuitously then the Puma and its development, the Oryx, those of you some of you might know that the Oryx is a serious upgrade to the Puma. The dynamics of the Oryx in particular, engines, main gearbox and rotor systems, offered very good building blocks, which we latched onto and decided we could hang an airframe on this and put systems into it. Clement is nodding, I'm happy.
The Oryx was the prime driver because of specifically the engine. It's the Kilo 1As versus the 1A1s.
Yes.
And the
Yes.
1A1s had the performance for the hot and high temperature versus
Yes.
the 1As.
Yeah, no, thanks for that. So yeah, it's in fact the same engine as on the Oryx.
Yeah,
Yeah.
exact same.
Exactly. So,
Oryx has got the same engine, gearbox, and rotor system.
except the gearbox is turned around.
Yeah,
Yeah. Okay.
that was a challenge, just for the record.
It certainly was. Just on that, and I might bump into it as we go along, the change to the gearbox was quite significant. The Puma Oryx engines in the front of the gearbox, facing forward, the drive into the gearbox, two drives into the gearbox, and then tail rotor and so on. With the Rooivalk, for reasons I'll get to in a while, we wanted the engines separated, can't do that and talk, separated for survivability reasons. Lose one engine due to fire, enemy fire. On an Oryx, you're probably going to lose two. So we separated them geographically on the aircraft. And that meant we had to develop combining gearboxes, which took the drive rearwards, turned it through 180 degrees and back into the main gearbox. So there were significant changes to the main gearbox. And those two combining gearboxes were works of art. They handled 1,500 kilowatt, and they weighed 70 kilograms each. And they reduced from 8,000
Yeah, it was
to
450.
the output was something like that. We're too old to remember those, but it reduced the output from the engine to the main gearbox, something like that, 8,000 RPM shafts. Yeah. And those gave us a lot of trouble balancing. Okay, so we decided then to use these building blocks with changes as we've just expanded on. And I like doing that, so anyone else who wants to interrupt, I can just open another little window and we can discuss that particular aspect as we go along. Thanks, Stu. Okay, I've essentially said that. Modifications deemed to be within the engineering capabilities of the RSA. So what I've just spoken about, the clever engineers and so on said, yeah, we think we can do that. There was also another very interesting item. Clement reminded me of it, was the vibration isolation system that was developed specifically for the Rooivalk. The Oryx, despite being a fairly smooth helicopter, vibrations, still had vibrations that concerned the developers of the main sighting system. You wanted a platform to be as stable as possible with reduced vibrations so that the sighting system didn't have to work so hard in maintaining a fixed line of sight. The line of sight stability requirements were huge to be able to detect a target the size of a tank at, say, 8 kilometers plus, and guide a missile to that. You needed a very, very stable platform. And I draw the analogy of the rock kestrel, and having his head stable and having good sight, exactly that applied. Yeah. And very interesting to note that fortuitously the size of the Rooivalk rotor system is very comparable to that of the Apache. So range payload comparisons are very similar. And they both have articulated rotor systems, which we'll talk about later when we come to the more fun stuff that we did for marketing. Okay, Stu? Sorry?
Did you deliberately look at what the Apache was doing?
No. Look, the overall design and shape of attack helicopters was kind of set in the early days with the Cobra, with a tandem layout, and there are very good reasons for that. So yes, that guided us in many respects. But I think just looking at the requirements from the floor up and what you actually needed to provide to the pilots, a tandem layout, for example, becomes the norm. Similarly, as I mentioned earlier, to separate the engines for survivability points of view is a good idea. And just by the way, we separated geographically all the other systems like hydraulics, electrical systems. They were both totally separate, and the data buses, and on either side of the airframe, just to limit catastrophe, total damage to system. Okay. So you guys will remember this, I'm sure. The Oryx, the fundamentals of it are the Puma. It had a new tail boom just to cope with the higher torque from the maquilas, which we mentioned. It had this little thing just to enhance a little bit of directional stability. That's an interesting thing we'll talk about earlier, just the slatted horizontal stabilizer. But otherwise, you can see side-by-side cockpits, engines together, and you can think for yourselves, I guess, as to the drawbacks of this in terms of an attack helicopter. The weapons and external payloads, that comes back to what the threat was, what the targets could be, what weapons do we need. So it was decided a fit or a suite of weapons, anti-tank missiles for armored vehicles and bunkers, aerial rockets for area suppression, troops, light-skinned vehicles, an articulated gun for soft targets and for self-protection. I'll mention that later. Stabilized visionics, we harp on this because it's very important. This vision, the system, the visionics, low-light TV, IR sensor, laser rangefinder, and a laser designator. First three are pretty obvious. The designator is used to designate targets for the missile to lock onto. A self-protection suite including radar and laser warning, and chaff and flare dispensing units. That goes hand in hand with trying to remain invisible to a searching enemy. Also to reduce the platform signature, IR-wise, infrared, engine IR suppressor system was fitted. You'll note if you just reflect on the previous slide that the Oryx didn't have any of that equipment, the suppressor. Stu? So, the anti-tank missile. The requirements in broad terms were to be able to take out an enemy tank. The tanks were really top of the list of threats that had to be countered. And thinking back to that first slide with the window of opportunity right at the bottom, 5 kilometers, that sort of thing, the range of the missile had to be at least 5 kilometers to take out a tank. If you just imagine how big a target a tank is at 5 kilometers plus, you can start understanding what is required. Now, the Makopa is very similar to the Hellfire missile in terms of capability that the Americans use on the Apache. Very similar, just because the requirements are similar. We used in the beginning the Ingwe missile, which is a shorter range, maximum range of about 5 kilometers, but also very effective in taking out tanks. It was a tandem warhead, a precursor, and then the main charge to take out the armor. We did a lot of work with the Ingwe, and there was quite a lot of progress on the Makopa, but for reasons of changed threats in Africa, the program was shelved, and it was never developed to be fully operational on the Rooivalk. So sadly, when the Rooivalk went up to the DRC, to Goma and those areas, it only was equipped with aerial rockets and the gun. Okay. Sad, but it's a very good missile it would have been. Thanks, Stu. Right, the gun, articulated gun, we've met this guy before. The basic gun is similar to that on the Rooivalk, but the development included this platform, this turreted housing mounting, hydraulically controlled via either of the two pilots' head movements, sighting lines, or for more accurate modes, using the sight, the visionic sight, which is controlled by the weapon system officer. So this is effective, very effective, up to 2 kilometers on soft skin vehicles, and it was very accurate. There was much debate, Clement, you might remember this, as to what caliber we'd use. There were the 30 millimeter proponents and those who said no, 20 millimeter is enough. The Army did a lot of research in terms of effectiveness and what was required at the target point, and they decided that a 20 millimeter was adequate. For us on the helicopter side, we were happy with that because it offered a lighter solution. Ammunition is lighter, so you could carry more, and we overcame the fear that a 20 millimeter burst you might miss, whereas a 30 millimeter would give you explosive effect far more for troops in the field and that sort of thing. So the engineers said, all right, no problem, we'll just make it more accurate, more stabilized. And that's what worked very, very effectively, and generally a short 5-round burst at 2 kilometers, you take out a target very, very first time. It was quite amazing. It had a dual feed, so you could load one type of ammunition, HEI for example, or just a blast type of cartridge on the other side, and you could select in the cockpit, depending on what type of target you had, which ammunition to use most effectively. Rate of fire, about 600 and a little bit rounds per minute. High velocity, muzzle velocity was over 1,000 meters per second. So roughly 2 kilometers in 2 seconds. You can kind of work that out. Okay, thanks. Stu? The aerial rockets, Forces de Brugge, Belgian rocket, 70 millimeters, folding fin aerial rocket. That's what that's all about. They're the folding fins. They sit in the tube. The fins lie flat in the tube. As it ejects from the tube, fins deploy and off it goes. So they free flight once launched. If your aim was good, you might be lucky. Generally an area weapon, but again, the refinement in the aiming algorithms done by the clever engineers was such that using the helmet-mounted sight or helmet-mounted display, you had an aiming point, and all the pilot was required to do is bring that aiming point onto the target and do all the calcs for you, pull the trigger, and you had a good chance of being successful. Okay, the next is just the rocket tube. You could carry up to 4 of those, 19 rockets per pod. So you could make quite a noise if you fired them all off in salvo, which is rather silly to do operationally. Particularly with an accurate weapon, you'd choose a smaller salvo to give yourself a second chance. Right, the stabilized main sighting system, I've spoken quite a bit about that, what it's got in it, and the need for it to be stabilized very accurately. And you can see that I think one of the videos later would show, you have to look very carefully, the gun being slaved to the sight. It's very interesting to see these two working in tandem according to the requirements of the weapon system officer. The sight also had features such as auto tracking, so the WSO could, for example, select a target, a moving tank or vehicle, whatever, press auto track, and it would follow that vehicle, saving the WSO from actually having to turn the sight as the vehicle progressed. Very good at night with the TV. Hot, cold targets presents a beautiful picture for aiming for the WSO. I use WSO weapon system officer. Okay. Lost again. Am I pulling something? Okay, I'll go into manual for a while. If you're there, Stu, just push the button. Okay, the general layout of the platform. Having walked all this road, decided what we want, how big, whatever, how are we going to lay this thing out? So, thanks, Stu. From what I've said about, it's pointless holding it. Oh, 1, 2. Okay. Is this voice accurate? Sorry. The view from the cockpit's gone again. Is it there? Needed to be exceptional to enable safe low-level operations. The term for this low-level flight is nap of the earth. I've mentioned that before. We've talked about the tandem cockpit layout. At this time, just to open another little interesting window, everybody was, the Italians, the French, the USA, were proposing various platforms to be used as attack helicopters. And Sikorsky, which didn't have a tandem layout, they proposed a side-by-side cockpit for the 64, the Black Hawk. Okay. And there was a lot of fuss made about you don't need to have a tandem cockpit and so on and so forth. And they lost that battle because, for very obvious reasons, the pilots didn't like it, the WSOs didn't like it, the frontal view, narrow frontal view, which is always a good idea in terms of being or avoiding detection. Have I gone again?
That was flagged. It's probably what's it.
1, 2? Okay. I've lost my train of thought. The side-by-side cockpit. So that reinforced our view that we'd go with a tandem cockpit to give each crew member a perfect, as good an external view as possible. Thank you. Stu? 1, 2. Okay, a gun and sighting system needed to be mounted on the nose of the platform for obvious reasons. And that's where you see the action, and therefore the nose wheel on the Oryx was ditched as a layout, and we went to a tail wheel design. Clement might have some comments on the ruggedness, robustness of such a layout in the crash case.
Get more stable crash.
Yeah.
The front one, isolation. There's only 3 points.
Yeah. So there were many advantages to that. I just love the term that, can you hear me? No?
I couldn't hear what Clement said, so just repeat it.
1, 2. I just love the term that Clement has just used, a stable crash. That's quite interesting.
It's even covered. If you look at the elevate, the crash down, the tow rotor always broke off. While with this one, the idea was if it crashes, you will be able to recover it and get it back to repair it again.
Yes.
Didn't have lots of that in those days.
And another sorry. Yeah.
Can you repeat that for us, what you just said?
No, I'm a bad listener. You'll have to say that again.
No, it's when you crash. Like if you have a 3-point in front, the tail rotor breaks off because of the crash landing. While if you have your tail wheel at the back and your 2 wheels at the front, you get a much more stable crash. You can recover the plane afterwards, because in the bush that was one of the big things. It's not only you were exposed to threats there, you also have to get your weapons out, because you don't want to let your weapons exposed to the enemy. Okay.
Another little window. We talked earlier about where we guided by, let's say, the Apache. I kind of covered that briefly, but just in a bit more depth. We weren't guided specifically by the Apache, but there were a lot of design handbooks and things available that we used to give us some direction. Some of them were good, some of them were not so good. I'll deal with it later, but yeah, sure.
Before you, or while you were designing this, did any of you go and fly or test fly any of those other military attack helicopters elsewhere, like the French and Americans, etc.?
No, we were boycotted at that stage. So
yeah, but I mean, you could
yeah, things are difficult to wangle, and yeah, those platforms, specifically the Apache, were obviously. Good morning. I'm sorry. Yes. Yes. Yeah. I very much liked the lapel microphone that you fitted me out with at your previous function. Maybe you needed to sell it to here.
Maybe, just to give context, the Oryx, remember the Oryx we didn't buy directly from France. The Oryx came via. So whatever, the Oryx was assembled in South Africa, but it didn't. It was supplied out of France, but it came via various routes into South Africa. In those days, I think Trevor, you were exposed to the same. I lost my black tag on the American visa system 5 years ago. Up until then, if I went into the States, I knew I would sit down and be interrogated.
Yeah.
And so we were watched from various angles. So to move around freely in the defense industry was not fun.
Indeed, thanks for that. And those airframes were actually manufactured in Romania. Yeah, and came through Portugal. There's still an ongoing case about that. Some businessman is still claiming royalties, but that's another big story. We were on the crash case, crashed safely. Crash? Stably. Stable crash.
Stable crash.
Sounds like my horse's stables. But anyway, the design point that we got from the American handbooks was for a vertical landing survivable by the crew of 11 and a half meters per second. That's quite fierce. Okay, we tried to get there, and we eventually, I say we, clever people, decided that we'd settle for 10 meters per second, as long as it landed fairly stably. Yes, okay. The case was actually proved many years ago when at Bloemfontein the squadron were doing a post-maintenance flight, and they're doing autopilot checks from the hover, introducing some of the modes. Things got a bit out of hand, and they actually crashed vertically. The crew both walked away. The aircraft needed some deep repairs. No back injuries, and they, from the data, measured that actual crash was at 10 meters per second. So that confirmed the design from the oleos to the crushable structure at the bottom of the fuselage below the crew, and Martin Baker seats, which were energy absorbing, to fluted. These fixed wing aircraft, you know what we do with them. Two fluted shafts, if you like, that had blades fitted to them to cut the flutes as the load increased, so that absorbed the energy, and they both walked away from that quite happily. So the design was proved. Yes?
That crash, he actually photographed that crash. I've actually got photographs of the aircraft coming down. And while we were taking photographs, somebody had posted a video from Cape Town, and all the officers got the video of this helicopter coming down.
Okay.
And we, the officer commanding on the unit there, told us to delete our photographs. And we said, no, why did we delete them? There's a video in around already.
It's a marketing video.
The SAF.
Yeah.
I still got one of those, a few of those photographs.
Have you got the video?
And I wrote the video.
Oh dear. That would have been interesting, wouldn't it? I could include that in a future talk. All right. So, where did we end up? Tailwheel configuration and expanded chats about that. So then obviously we needed a weapons beam, which we called it rather than wings, to do the weapons carriage of the weapons that we've just discussed. It was not designed to be a lift-producing wing. It was purely a low-drag aerofoil. Didn't produce any lift, as opposed to the Mi-24, which has a wing with a high incidence, and at cruise speed it actually generates about 20% of the lift, so it offloads the rotor, but we didn't opt for that. We didn't think that speed was a major requirement for an attack helicopter in the role or the way in which we're using it, nap of the earth and so on. You quickly ditch speed as top speed as an attractive option. So that's how the wings ended up. There's an interesting story when you get to the layout. Thanks, Stu. This is an important one. Okay. So when operating in this little window that I described earlier, it was essential to follow this mantra that all the designers followed. It was laid down by Dr. Paul Potgieter as a very basic guideline to ensure the survivability of the Rooivalk. So we can just go point by point. Avoid being seen. Okay, number one. Visually, noise, radar, whatever other detection devices the enemy might have, don't be seen. Fly low, stay out of radar, have a low cross-section, frontal section. Stu? If seen, and you will be seen at some stage, avoid being hit. So we had onboard sensors like radar warner, laser warning, visual, there's smoke or there's something there. Avoid being hit. The way to do it was use the agility of the aeroplane, get out of the way, take cover behind terrain. Then if hit, avoid a crash. We've talked about dual systems separated geographically on the aeroplane. So if you are hit, make sure that the whole aeroplane doesn't, within reason, fall apart. The design was generally for 12.5. A 20 mil is a serious weapon, so if you're unlucky enough to be hit by a 20 mil in a bad spot, well, that's just not your day. You cannot design for anything, for everything. The control rods, for example, were sized in diameter to be able to accept the 12.5 hit and still remain intact. Now, that's the level of thinking that went on. Okay, and then the next one, if you crash, help me there, what do you do? Crash safely, yes. So again, within reason, if you crash like this on your side, it's going to be difficult to walk out of it. However, the pilots would attempt, as far as possible, to land as near proper attitude as possible. And that we've talked about the undercarriage, the oleos, the crushable structure, the seats. Yeah, and then of course the aircrew had their own protection, helmets, and so on. And they could get out quickly with jettisonable frangible side panels. They were explosively jettisoned, so pull a handle and both the side windows would be fractured and jettisoned. The guys could get out that way. Thanks, Stu. All right, the layout then. Let's go through just to summarize where we've come from. So the gun, the sight, the tandem cockpits. You can see here that they are step tandem. So the forward view from either cockpit is identical. And the side view, you sit pretty close to the glass so you can see pretty much around you. There were mirrors fitted as well to observe in the rear section of the aircraft. Then the whole engine section, sand filters, the engine is a small part of it, and then the infrared suppressors over here. This is an early, this is the XDM experimental development model, the first prototype, and these weren't yet finalized. The wing, weapons beam, with some of the original envisaged weapons fitted. They had also an air-to-air missile, just to keep some parts of the Air Force happy that this thing would be able to defend itself against fixed-wing aircraft. But that requirement was ditched sometime later when further trials were done showing that actually that wasn't too much of a threat. This section remains fairly intact in terms of modification. There were huge developments around here, the fin. Let me expand a bit on that. So mentioning the mill standard documentation that we had, there was a big push in the documentation to make sure that the directional stability of the aircraft it met the requirements of directional stability, and that's defined in detail in the documents, at up to V&E. In an unaided system, in other words, without any autopilot stabilization system, that's fine in a particular attack helicopter role where high-speed attacks are more common, particularly the Mi-24, for example, which would do almost fixed-wing-like attacks. So this is the reason we had this huge fin, was to ensure that we had that stability, and all those sums were done by the aerodynamicists. But what happened later was that when we started looking at the employment, tactical employment of the aircraft, this thing was a great problem in limiting our sideways flight capability, the agility part of things. So the decision was made that we're going to ditch this high-speed requirement because of two things. The first thing is that the autopilot capabilities had improved from the days in which that particular mil-spec was written, and the artificial ways in duplex manner of ensuring that the stability at high speed was managed. The second one was that we desperately wanted to get the out of wind or the sideways. When I talk of out of wind, it's flying sideways, backwards, or accepting a wind from either direction or any direction, so that the weapons could be deployed. Bearing in mind the enemy might be there, the wind could be coming from this side. And we pegged a value of 50 knots in any direction as being desirable. Wind speed of 50 knots at any speed, at low speed in the hover. So you'll see in the later pictures that we have, this thing was significantly cut down, primarily to give us the 50 knot capability. We also later in a demonstration to the United Kingdom team that came out, you remember that? We did a demo at Rooivalk. They wanted to see the rearward speed, and we showed them we could fly 70 knots backwards. That was quite an achievement. This is an interesting thing. Clement, I'm going to rely on your history there as well, but the story I have, if you look here, these wings are swept backwards slightly. Now, in the early days of the development of the sighting system, it was a huge and heavy sight, which put the center of gravity of the aeroplane too far forward. So in order to counter that, they developed a swept wing just to move the overall CG further backwards. You see the later aeroplanes were simplified from the manufacturing point of view. It could move to straight wings because the sighting system had become much lighter. Technology in those days, in terms of electronics and cameras and things, developed very quickly. So those are quite interesting aspects of this first layout. Okay. Thank you. Sorry, guys. Okay, associated programs, we've had a chat about those earlier, thanks, Stu. Okay, when we spoke about the early 90s, the program or the requirements were actually seen much earlier in the mid-80s. There was already thinking about how we're going to, in the country, produce an aeroplane platform that could give us the ability to take out armor, tanks, that sort of thing. So there was a thing called the XH1, Alpha XH1 program, Experimental Helicopter 1. This was just a capability demonstrator. It incorporated the basic attributes of an attack helicopter, a tandem cockpit, a tailwheel layout, some enhanced directional stability. We put on a mock gun in the front, just an old MG151 cannon that was strapped on. And this flew first on a Sunday, 1985, which was an unofficial flight carried out in great secrecy at Air Force Base Waterkloof. Couple of interesting things. Laura, you must tell me if I'm running too late. Just you're happy? Yeah, I should have mentioned that in the beginning. Very interesting things. A similar error was made regarding the fin, based on the requirements that we understood from NOL standards. Pilot sat in the back. weapons system officer. In this case, it was just a flight test, not just a flight test engineer, it was the flight test engineer who sat in the front. He didn't have any weapons to operate. We were just doing the structural testing, structural performance and handling qualities testing. This is a very interesting piece of kit. The engineers, Dr. van Rooyen, was very interested in what happened on the rotor head. So he fitted strain gauges, accelerometers, etc., on the rotor head. We didn't have a means immediately of transferring that information down to an onboard recorder. So they built this telemetry transmitter, which accepted all the information from the transducers and sent it out. Now, it was one of the first, I think the first use in South Africa of an airborne data transmitter, flight test instrumentation data transmitter. And the heart of that, very interesting story, came from CSIR. They developed a data transmitter for measuring the heartbeats of racehorses. So that's the origin of that particular piece of equipment. The first flight was done in secrecy, quite successful, and then a year later, in 1986, it was flown at Denel Atlas Aircraft Corporation, also on a Sunday, and we flew a total of some 6 hours 45 on the machine. It had two main problems: the fin, which we could only get up to 80 knots before running out of pedal authority. That was the one that limited. In other words, the fin was too effective. We took too much cognizance of the MIL standard requirement. And the second one was vibration. There was some mode in the vertical mode rather, in the airframe, which responded to the 3 per rev of the main rotor. And Clement might remember the audio from the cockpit. It was like me talking. It was quite severe. So we weren't able to solve that, and there was no need to solve it. The one thing they did, I think it was a piece of MIL standard blow dart. They strapped the end of the cannon just to see whether it was possibly the cannon but it wasn't. So that was it. It did its job. The Air Force was quite happy. I'm back online. The Air Force was quite happy that the team, and that was done under the auspices of NIAS, National Institute of Aeronautics and Systems Technology at CSIR, under the leadership of Dr. Paul Potgieter. And the team, which was very small at that stage, had proven satisfactorily to Arms Corps in particular, Air Force obviously as well, that the country had the capability of tackling a far bigger project. The other associated programs, the project purchased 2 J model Pumas from overseas, civilian Pumas, which were then dedicated to developing systems. There were 2. There was one, a 189, and the other one, Puma 190. They were just given Air Force tail numbers, if you like. For those of you interested, 190 is now currently under refurbishment at the SAF Museum. There's a very enthusiastic team of guys who go and spend Saturdays polishing, replacing parts. It was terribly vandalized because it had stood without supervision outside a hangar, and cabling was stolen, instruments were stolen, but they're slowly restoring it to its former state. So it'll have the wings. They might be able to scrounge a site somewhere from Kentron, but this included the, let's say, hang-on things that later were envisaged to be put on to the Rooivalk. So the weapons, there's a V3B anti-air missile. There was a gun underslung. It used the cargo hatch. Gun was then extended during flight, just to get some initial design information on the crew interface with these weapons. And then, thanks Stu, the Oryx program, I think I've probably spoken more or less enough about that. Common dynamic systems. So these all ran in parallel, and to a greater or lesser extent they were in support of the Rooivalk design, which was kind of ongoing in parallel, because we first flew Rooivalk in 1990. So you can see the 1986 to 1990, that was where all these converged into the XDM, experimental development model of the Rooivalk. Thanks, Stu. Just another view of the Alpha XH1. Just some tape covering some of the test instrumentation. You see some of the old temperature stickers there. There were accelerometers up there. Everything that could wobble or vibrate was instrumented, and all sent via this telemetry. The range was very short, so the flights were likewise in close proximity to either the ground station at Waterkloof or later at Denell, Atlas Aviation. Stu? Okay, there's a better picture of the Puma. I read a very interesting article sent to me by an historian in Cape Town. I forget his name right now, it's just come to mind. And he explained the devious way in which these two aircraft came into being and were placed on the Rooivalk program. And something I didn't know about, which concerned me when I heard it, was that they, at the time we were testing, and we used Air Force tail numbers, they were still registered on the CAA civil register, which caused me some concern. No one said a word about it, but yeah, this historian picked that up somewhere. But I guess these are bygone years. Hope the Mandlanga Commission doesn't sit too much longer. Thanks, Stu. Next one. Just another layout, a marketing type layout called a Puma gunship. There was at one stage, there were thoughts by some people, despite what I've said earlier, a side-by-side cockpit not being absolutely ideal for the job. There were thoughts of marketing the Oryx as a poor man's attack helicopter that never obviously went any further. Stu? We did a lot of testing down at St. Lucia. They had a test range at Lake St. Lucia, run by Kentron in those days. And there were a lot of testing done. This is an Ingwe test. And the point of interest, apart from making sure that the missile cleared the aeroplane, you can see the pitch was fairly nose down to make sure that we didn't hit anything. But a major concern in the later Rooivalk development was the ability of the tail boom, the kind of vertical surface of the tail boom, the flat part of it, and that was done for other reasons, the ability of that to absorb this blast pressure, which is quite significant. The Ingwe missiles were subsequently modified because they were ejecting a lot of the igniters and the stuff, cabling and so on, which on a Rattle didn't cause any problem, but on a helicopter it was a problem. So there were some changes required to the Ingwe missile for this. A lot of testing was done down there. We did the underslung cannon testing, some sight testing, just a piece of flight test instrumentation, yaw, or side slip rather, and pitch angles, etc. Thank you. Just another pretty picture. Okay, we can scramble through. All right, a lot about the outside. Let's talk a little bit about the inside of the aeroplane. This is a very early photograph and probably not entirely accurate for the production aeroplane, but nevertheless it gives you an idea of the automation that we tried to put into the aeroplane. Bearing in mind this is 80s, very early 90s technology that we managed to achieve something like this. This is the weapons system officer's office, and he has two handles here. I don't have a photograph of them, but they actually pull out and rest in this attitude, and he uses those two handles to control the main sight, to control the gun if required, and also to select the various modes on the sighting system. So he operates those two levers. Otherwise, the two cockpits are virtually identical for training purposes, for maintenance purposes, production, all those sort of reasons. Flying controls are identical. You can't see the collective down here. A multifunction keyboard here, which was for its day quite advanced. And two multifunction displays, which gave the crew oodles of options of interrogating aircraft systems, setting them up, setting burst lengths for the gun, for example, the rockets, checking fuel, payload, a number of very deep options available to the crew. There's a dedicated radio frequency panel there, which for reasons of tactical ability to change radio frequency very quickly, all pre-programmed in a data transfer device. So the crew would sit in a tactical planning center, and they could plan the whole mission, waypoints, frequencies, weapons loads, fuels, whatever, put it on a data transfer device, stick it into the aeroplane, and the whole mission is then loaded and off they go fairly automatically. So the major push, and this is obvious if you think of the environment in which the aeroplane was designed to operate, low level, at night, 50 foot at night. There's no time to fiddle in the cockpit. There's no time to have steam-driven instruments and so on, which are difficult to interpret. You have to make sure that the crew has eyes out at all times, as much as possible, and that the data comes up automatically as required at each particular phase of the mission. So, for example, if they were setting up for a anti-tank missile launch, select anti-tank missiles, and the displays would configure themselves automatically to suit the requirements, the inputs that the crew want for that particular job. Radio frequencies were changeable on the cyclic. The hover modes were engaged on the cyclic, for example. There were automatic hover, hold, height and position. And because of dust and what we call brownout conditions, there was a button that a nervous pilot could press if he couldn't see all that well. And the aircraft, via the navigation system, Doppler and the inertial platform, would attain and maintain a stable hover without the pilot being able to see the ground. These were the safety issues, systems, for example, that were put into the aeroplane. Thanks, Stu. Again, a very early helmet design. Reduced workload by presenting all the flight information necessary on the pilot's or both crew members' visors. So he could be looking out there and he could still access data that he needed from the aeroplane on his visor. Again, very early, but the two night vision tubes, not goggles, but the tubes, which were then, the visuals from these were transferred and put onto the helmet as well. So you had a picture, a green picture, because of the nature of night vision goggle presentation, a green picture of the terrain outside. A very interesting and at first a very challenging result of having the night vision sensors on the side of the pilot's head was that it led to a condition which is called hyperstereopsis. So when we view the world through our natural eye, and the interpupillary distance is so far we're able to judge distance and so on. The further out it goes, the more distorted image you get. So my first experience with that was during landing, where because of this hyperstereopsis, you land and you land and you land, and the terrain appears here. So you actually feel like you're landing underground. But this is something that the pilots get used to. So each feature has its drawback in one way or the other. The much later helmet was far improved from this pre-production type helmet, and it was the one that's in production and fitted is used on some of the American equipment right now, developed by a French company. Very good, Top Owl they call it, equipment. Thanks, Stu. Spend hours on this, but just to give you a rough idea, and I'm sure you've all seen head-up displays presented on visors just in picture form. This is just one of the early representations of that. So you'd have important things like radar altitude. It had a radar altimeter, very important. Attitude, speed, status of the weapons, and various other indications. Very important one here is where's the target, distance, and a bearing to the target. This has been changed significantly, I think, to make it more readily usable by the crew. Next year. Frontal aspect, we've talked about that. Just an illustration, there's the pilot, great forward view, weapons system officer, great forward view. A narrow cockpit, granted. The engines do protrude significantly from the radar point of view, but then so does the rotor. So all the more reason for being able to fly low. Don't stick your rotor up above the hill. Keep it down. Fly in the valleys, fly low. There's an interesting thing that wasn't, I apologize, I keep getting this at a non-optimum distance. This was called a pilot night vision device, and it was its own sensor, night vision sensor, coupled to the pilot's head movement. So wherever he looked, so did that, and it presented that image on the visor. But that was never taken beyond development, and it's not fitted in production, sadly, because it's a great attribute. Thanks, Stu. That's XDM. Okay, no IR suppressors, just notional guns and so on. We talked about this very briefly when I pointed out the Oryx and the horizontal stabilizer. This again was a brand new development, just a plain aerofoil, just to give the right pitching moment generation at whatever speeds you're at. But for production reasons, subsequent to the flight testing in terms of longitudinal stability, it was decided to ditch that and use the Oryx horizontal stabilizer. Now that has a slat in the front, on the leading edge, inverted obviously because it needs to operate, keep the nose down. And that was put on because of the high excess power of the aeroplane, and particularly low speed, very high rate of climb, the stabilizer would stall. So we went back to the Oryx system. They'd already found that out. I don't know why we ever designed one of our own. There was also some vibration problem on the original one. They fitted the Oryx one, problem solved. You remember that?
It brings back memories. I'm trying to think exactly why, but I think it was the level of design already that's been done that said we stay with
Yes. Find out.
Switch it over.
Yeah.
The flybot was, remember we had a few deadlines to make with us.
Yeah.
No, maybe touching on the critical deadline we made on that.
I haven't. No. Okay.
I'll give you the right. There's one date that actually, in fact, makes this helicopter very special. Okay. Talk later. So from this design, the major, and I've got a whole talk that I do on, I call it Rooivalk tail feathers, on the development of the tail feathers. So this was ditched, that was changed. There are various other devices like a gurney flap on the back,
This was significantly cut down, all in the interest of being able to fly sideways or accept a high wind from either quarter, any direction on the helicopter. Still had the swept wings. Yeah. Thanks, Stu. This is an interesting, just to relax the minds a bit, painting done. Some of you aviation buffs might know the name Tiro Forster, who was a very well-known aviation artist. He was commissioned to give this notional idea of two Rooivalk in the operational area. This is the Omarambo down here, some tree line. It was in the XDM configuration, the first one. The Ingwe rockets, while it comes to mind, very interesting on that, which we ran into when we did our marketing. The manufacturers of the Ingwe were very nervous that people would determine the diameter of the missile and therefore its effectiveness against the target, because diameter is very important. So the rocket launchers had a deliberately reduced diameter for each of the missiles, just an outlet. Obviously, they were never fired. It was just for deceiving those who wanted to know more about the aeroplane. Okay. Oh, yes, while we're on that, remaining unseen, while I think of it, the intention was to keep all the glazing, the windows, front windows, side windows, flat for purposes of glint or reducing the glint. If you just think about a curved surface, sun shining on it, the glint would stay for quite a while as you changed aspect to a view on the ground, as opposed to a flat surface where it would be a blink. Okay, so that was the design. Unfortunately, these became a bit wobbly, so there was a slight curvature put to them just to make them more stable. Okay, sorry, I digress as I go along. Thanks, Stu. Another version of one of the first flights of XDM. Thank you. Okay, so I've spoken of the changes, particularly here, XDM. Just I'll push this one, Stu.
Yeah.
1, 2. Oh, there's another one. Okay, let me step on. Okay, thank you, Stu. Significant changes. Sorry, it's slipped off the bottom, but we won't adjust it now. Straight wing, IR suppressors, cut down tail, and this one at the top, that was a, what was it called? What was the term for it? I've lost the term, but it's an airspeed sensing system which will give you your airspeed in any direction. So it was a little propeller thingy that spun at a certain rate with 2 ports. Low airspeed No, not an anemometer. It had 2 kind of wings like a helicopter, 2 blades, little holes in each of them, and by differential pressures they could work out where the wind was coming from, or the airflow was coming from, and also the speed. Yeah. That was very useful for the low speed environment, so you could actually determine the wind from that if you knew your own flight parameters. So very useful piece of kit to have, and that would also be displayed on the helmet display. You'd know where the wind is coming from. In the hover, it's always very important to know where the wind's coming from for aircraft control purposes. Thanks, Stu. 2 production aeroplanes. Nice picture.
How many were built?
Eh?
How many were built?
12. 12 were built, yeah. Next, Stu. Okay, flight testing. I think a lot of you would be interested in this, and I'm not covering it in much depth at all. So let's kick off on that, Stu. So there were 3 development models. We've already had a look at the production, which doesn't feature here, but XDM. Okay. Experimental development model, the XDM, used for basic airframe structural tests, performance and flying qualities assessments. Clement and I were discussing earlier the huge task that went into gathering data and the parameters that we recorded on board and also transmitted down to the ground test station, which was manned by a bunch of experts, the designers, flight test engineers and so on, so they could monitor various parameters in real time. And there were well upwards of 1,000 parameters that were recorded for each flight. So that is temperatures, pressures, vibrations, strains, airspeed data, engine data, a whole pile of stuff which was recorded. So that was the primary use of XDM. Did a lot of handling qualities testing. That's when we first ran into the problem of the fin being too big. Next one, Stu. Advanced Development Model, ADM. Carl, you'll be interested to know that I fixed that. Don't know if you picked it up. You can fix your presentation. I had EDM there instead of Advanced Development Model. It was used for testing changes resulting from the XDM tests and for evaluation of the initial avionics suite, as well as some weapons tests. That was the Advanced Development Model. Also included in that would be vibration, in particular the system that Clement worked on, and we discussed earlier, the vibration isolation system. A lot of data was gathered from that. And I must say, from a helicopter pilot's point of view, that system gave the Rooivalk almost fixed wing-like levels of vibration. It was amazing, really.
Point refers jet smooth ride.
Jet smooth ride, yes.
Are you touching on the date of first flight? Mm-hmm. Are you touching on the date of first flight of the XDM?
11th of February 1990, first flight.
Yes, at 8:20 in the morning.
8:20?
Yeah.
Prachtig.
But what happened at 2 o'clock that afternoon?
I think I'd had too many beers by then. I'm not sure.
That's also the reason why these aircraft had such a difficult time. Nelson Mandela was released. And we had to fly that morning
Okay.
to prevent the exposure. There was no senior officer above the level of brigadier at the test flight. Because no general was allowed to be at the flight.
Okay, I didn't know that. Okay.
Because of Nelson Mandela's release, there was a total embargo on the flight. So it was the greatest day of South African aviation history of a designed aircraft. And nobody knew about it because Mandela was released that afternoon.
Thanks for that. I'd completely forgotten about that.
That was
interesting.
If you go in the history, you'll see that is absolutely downplayed because of and that's
My word.
He battled to get it back into all the defense programs because of the conflict with Mandela.
Interesting. Politics always has an interfering factor, doesn't it? Okay. No, thanks for that. Okay, then the last one was the engineering development model used for testing to finalize the initial production standard, essentially, in broad terms. Thank you, Stu. Okay, we then went into marketing. We were overconfident, I guess, naive, but there was a great push to see whether we could sell this aircraft overseas. And there was a lot of money spent, and it gave us a most enjoyable couple of years, fantastic flying, but there was a significant amount of time spent on marketing. Thanks, Stu. So we obviously, the government, whoever, Arms Corps, Air Force, particularly Denel, which changed its name to by then, wanted to enter the world market. Stu, thanks. Expensive campaigns. We did marketing in the United Kingdom, Malaysia, Saudi Arabia, Algeria, and Australia. where we transported the aeroplane in mostly the 171, Antonov 171, and also C-130 to Cambridge, for example. So we took part in the next, thank you, Stu, major air shows, and these were the fun things. A lot of nice flying at Farnborough, Dubai, Langkawi in Malaysia, and in Australia. We had a particularly big program in Australia. Stu? Before I go into this, Australia, we had huge support from the military because Australia is a big country, range payload requirements, simplicity and so on, very much in line with our thinking and what the aircraft turned out to be. The users, the Army guys, Australian Army were going to buy an attack helicopter. They loved it. But sales were stifled by pressure from the USA for obvious reasons. They wanted
Dirty tricks.
No,
That's really.
it's looking after themselves. Yeah. All is fair in love and war. So, yeah, they kept us out of the market. Yeah, and we lost. The major reason...
the story about the king.
the
The UK at Farnborough, the first flight at Farnborough. Prince Philip would have flown in the aircraft.
full of?
Prince Philip
Oh,
would have flown.
no, it wasn't him.
It was,
It was...
Trevor, can't hear you with
I'm sorry. I'm sorry, Cole. I'm sorry.
I'm so interested. What are you?
I can advise to get these things too. You got them. That wasn't at Farnborough. Farnborough was interesting from a number of aspects. We'd initially, our marketing guys at Arms Corps had concluded some sort of arrangement with the manufacturers of the Hellfire. Is it Martin Marietta, I think, TC? Yeah, anyway, that we would jointly market the Hellfire on Rooivalk. And they provided us with a whole set of dummy missiles, which we flew on one flight at Farnborough until there was intervention from on high in the USA. No, so those were taken off. Yeah. The one you're referring to, and Laura, do I have enough time to carry on?
How long?
Probably another 10 minutes. Is that okay? No breaks needed? Okay. I'm just trying to think of who's the history buffs. Not Prince Philip. When we did the display at Middle Wallop, which is a big Army Air Day helicopter related, Middle Wallop in the United Kingdom, we had on our side, on the marketing side, an ex-chief of the United Kingdom Army. His name was Lieutenant, or General rather, Simon Little. Now, his surname wasn't very good because he was a huge man with a booming voice. And he'd retired from the army, but he came on board the Rooivalk program to advise and smooth the road politically and so on and so forth. And he's a very influential man. And at this particular air show, my flight test engineer, Egon, and I, we'd already briefed, we started getting into the cockpit, all the equipment on board, and this black car arrived, and here was General Little, followed by a little corporal who was stamping his feet all over the place, and the corporal said, "The General wants to see you." So I hopped out and I said, "Morning, General, how's it going?" And he said, "You're going to be flying," I must think of his name. He used to be the patron of Wimbledon tennis.
oh, yeah.
Do you know who I'm talking about? Very nice.
Ken.
It could come to me later, I hope. A very impressive looking gentleman. He was an army qualified pilot as well. So he said, you're flying him. And I said, I have a big problem. Nothing's been arranged. I'm worried about the politics and all that sort of thing. Sorry, Carl, politics. And he said, my boy, don't worry, I will fix it. So I said, okay, and he called his corporal, and I must admit, I'm going to relate this word by word. He said, corporal, and this guy in true army fashion, who's ex-army here? Anyone? And this guy came running up, cracked the concrete, and one of these salutes, you know those fancy ones? Yes, General. And he said, corporal, go up to the tower and tell them that this is a VIP flight. They're going to be taking part in the show. This corporal's eyes widened, and he, yes, sir, and he did this about turn, stamped his feet, and off he went. Close your ears, you're sensitive. And he called out and said, corporal! And the corporal said, sir! And he said, don't fuck it up. So we were then, I had to evict poor old Egon from the cockpit. I had huge misgivings about doing it. I suppose the pressures are there. Anyway, what a nice chap he was. We went out into the holding area before he went for the display. He flew around a bit very nicely, and I said, we're going into the display now, are you happy? Because we're going to do some aerobatic maneuvers. He said, it'd be lovely. So we did our whole display with this gent on board. I thoroughly enjoyed it, but when we got back, of course, there's hell to play. There were objections from all over. But General Little, true to his promise, he squashed everything. We never heard a word about it. So, okay, you put me onto that long trail, but thank you. All right, so getting back to this, one of the major reasons, sorry, Carl, is that as we found out in the Australian campaign, countries were, quite rightly so, not prepared to take the risk of buying a system which had a projected lifespan of some 30 years and put the trust in a country like South Africa, which was in turmoil at that stage, particularly industry. So they said, too much of a risk, and they bought the French Tiger, which disappointed them hugely. In fact, they've already got rid of them. So that was the end of that. That's the marketing campaign. Okay, thank you. Right, here's something related to that, and I popped this in. Carl, you haven't seen this one because of the EAA component here today. Flight testing and data I thought would be quite interesting. So this was during the development of the aerobatic program maneuvers that we proposed. And this was the first time that we'd gone inverted, and this was given to me in the briefing by Dr. Donnie Viljoen. He was in the back room, and he said, first Rooivalk barrel roll from the backroom boys, and that was done 13th of the 8th, 1993. The interesting thing here is the roll attitude. He summarized it here. He just said roll attitude is phi in test flight talk. There we go, inverted and back to normal. So the roll rate we achieved, for those who are interested, 40 degrees per second. And the G was from 2.2, which was the pull out, and at the top, some 0.6 G. Okay. From there, we developed a more straight roll. We developed the loop, push over, and a vertical roll, and various other maneuvers which we flew at Farnborough. Thanks. I'm nearing the end, guys.
How many seconds did you say?
40 degrees per second. Roll rate, phi dot. Yeah. I was confused as well, don't worry. Okay, here's an early marketing video. I apologize for the quality. Stu, if you could maybe just turn the volume down a bit. It's just music. turn it down. So I'll use this time if there are any further questions coming up. But in the meantime, this is a very early marketing video which does show some of the attributes and some of the ways in which Rooivalk was intended to be used. So questions, please. I'll let you mull over that a bit. There's a nicer and more modern video just to settle things at the end of this. So effectively, I'm at the end of the talk, and over to you, guys.
How many of the development aircraft they're still sitting in the nose? ADM, XDM.
XDM is in the museum at Swartkoop in a fairly dilapidated state, and I believe there is a team being put together to kind of refurbish it and get it into a respectable condition. Clement, I don't know if you know, I think EDM became one of the first production aircraft.
Correct.
Yeah.
ADM,
Yeah.
you bastardized ADM to make EDM, and then you make EDM.
And production. There we go. Yeah. Yes.
ADM and EDM won't exist in
Yeah.
a tenable form anymore.
From the horse's mouth. Thank you. So yeah, the only prototype is there for XDM and at the museum. Those of you been to the museum, or those who haven't, make a turn there one day. It's quite interesting. Yeah, Alpha is there. There's a Puma there. They're restoring the J Puma and XDM. Yeah, there.
You did the development with the England missile, the Makopa has replaced it?
The Makopa was intended to replace it, but it never did. Yeah. And in fact, the Ingwe, apart from doing the initial testing, was never put into or never fitted in the production machines. I think they did 1 or 2 test firings of the Makopa, just to look at structural issues, blast and that sort of thing, but it was never taken further. There's some of the arrows.
So what was wrong with the French Tiger?
Nothing. Well, the Australians wouldn't agree with that. In my opinion, it was too small for the size of the country. Australia is vast. It's a smaller rotor. The Rooivalk's generally an 8.5 ton class helicopter. The Tiger's about a 5 and a bit ton. So it's significantly smaller range or lower, less range and less payload. Yeah, they had a very very sad accident during their marketing campaign. It was just before we got there. The French had sent out the Tiger to demonstrate to the Australian Army, and one of their initial night test flights, something went wrong between the crew. Coordination, cooperation, misread the radio altimeter and they crashed. But they survived, and they also called out a demonstration of its crash worthiness. But the sad thing came later when, due to technical issues, they didn't get Eurocopter didn't get the promised progress in terms of the maturity of the airplane in place. There were maintenance issues and so on, so they ditched it. One of the reasons also because the requirement changed, as it has changed here, as I mentioned earlier. We no longer have that scenario where helicopters are actually useful. They're actually very vulnerable. A drone in the tail rotor is the end of the helicopter. Yeah.
Performance comparison with the Apache.
Very similar. Very similar. Same, broadly speaking. On the basic airframe factors, speed, range, endurance, all very much of a muchness due to the rotor size and the size of the engines required to drive that. You end up with more or less the same performance. However, they've significantly, because they've had time, they've got the resources, they've upgraded avionics significantly with tactical radars and all sorts of things which we never dreamed of. So from that point of view, it's far superior now to what our Rooivalks are. The basic platform is much the same.
So quite an achievement.
We think so, yeah. And as I said earlier, it was not only the Rooivalk, there's the Rooikat, there was the Ratel, and all those other programs that were running in the background to us who were so focused on the Rooivalk program. You didn't realize these other huge programs were on the go. There were the space launch rockets being developed down in Overberg. What else?
Remember, if you go back to that picture, that was our whole warfare
Yes.
scenario. So you had from the modern soldier to the Ratel, to the tank, to the Rooivalk that operates in the land. And then you had the Mirages development there, and then the missile developments that kept.
Exactly, those were the other ones. I forgot. There was a big fixed wing. Well, you all know, I guess, about the Cheetah upgrades, okay, which was very much Israeli based, based on their Kafir, but again a huge program because it was significant changes to the airframe. But there was a much larger program that was running called Carver. Carver was a generation 4, I think, fighter aircraft, twin engine, a lot of activity, but this eventually caught up with it. It just became far, far too expensive.
That stage on Rooivalk, there was 280 engineers, and there was about 300 engineers on Carver. So just at Atlas alone, there was more than 500 engineers, of which the average qualification was postgraduate. So they weren't normal PhDs, it was honors degrees, master's degrees, PhDs that were sitting at Atlas. So that's just on these two programs. That excludes the Rooivalk program, excludes the main battle tank program that was also going
That's right.
which was a replacement for the Rooivalk, which never came to fruition. Plus, and then at Kentron, there was also a couple of hundred engineers there. So if you just looked at what this did to the engineering knowledge base of South African defense program, it was astronomical. There were 1,000 engineers in those sort of programs.
I think personally, I was very lucky, extremely lucky. I rode the crest of the development wave, and I think all the young engineers that were involved in these various programs drew the same benefit. Extremely lucky. I mean, today these opportunities are just not there for local guys, which is very sad, but I had great fun. Yeah. Lastly, I just want to play the other one, but before you do, I just want to give credit to the guys who, and I can't remember the names. Okay, the next video, I thoroughly enjoyed, and I think it encompasses a lot of the attributes of the helicopter, the way this guy, Major Corné Stadler, presented the aircraft earlier this year. Yeah, we well progressed in the year, yes. At one of the open days at Swartkoop. And the guy who did the filming, Gerard Maynard, also give him credit for this. So this is the final bit. Enjoy it, and welcome to answer any more questions if you wish. Sorry, I'm standing in your way. It's 5 minutes.
Okay. Apparently we've got to watch this first. I've just been told by the PR.
Sorry. Lack of coordination on my part, sorry. hasn't taken too much time.
When was this done?
Earlier this year, I think it was about February.
So how many are still flying?
They've lost all maintenance capability.
So this one's not flying.
Just about, yeah. See the gun. It's a helicopter.
Yeah, but I mean, like, I've seen helicopters fall on the airfield. Does it?
No, they don't stall. They get into a vortex condition.
Yeah.
Yeah, but it's different to it's been stalled.
I only fly airplanes. I've never flown a helicopter.
You should try helicopters. His final bow. His final bow. I think that's it. Yeah.
I think those of us that have been to Oshkosh have seen some funky things with helicopters, but this would ask you any of those.
No.
You need to get it on to America.
No, it's quite casual.
Thank you very much. These photographs are gifted to you by Andre.
Oh, thank you. Yes.
So,
thank you, Andre.
Thank you, Andre.
Thank you.
They're very beautiful. You want to hold them up and show them to the audience?
Done by Andre. Super. One of the displays where they eject all their infrared flares all at once. It gets very hot in the cockpit. And one of the white painted United Nations helicopters. Yeah, all for support. Thank you.
Trevor, that was very informative. And yeah, we appreciate it. I think everybody here enjoyed it.
Thank you.
Thank you very much.
It's a great pleasure. Thank you.
Did any of the airframes ever serve in active duty?
Yes.
And did they earn any battle honours?
I'm not sure about the battle honours part. That I don't know. But I do know that they served up at Goma in the DRC. And I was privy to one of the talks by one of the pilots who actually flew in those missions during that time. Very informative, and the airplane performed very well. The United Nations was at that stage operating a couple of Mi-24s, and I think they had two Rooivalk there. They had two Rooivalk, and the United Nations always preferred to use the Rooivalk rather than the Mi-24. So yeah, the particular sortie he related was a very successful one where they were called up at short notice. The target was identified. In the first round they couldn't get through because of very low cloud. They refueled and went out again, and they took that target out 6 love. So it was a great success. Yeah, it was used, but they've now been withdrawn. They're back in the country, but sadly, I was just discussing earlier, none of them are flying anymore due to maintenance, cash, planning, all the typical stuff. Sorry?
So what, yesterday? 3 are up in the air already.
Prachtig.
Yeah.
Hey, okay, that's good news. Where did you see this?
OG picked up one on Thursday and took it back home. Thursday? Yeah, Thursday.
Oh, excellent.
Was it yesterday? I can't remember.
Good news. I'm delighted to hear that. Thank you.
There's possible the fourth one is about to come back as well.
Sorry?
The fourth one is about to come back.
Excellent.
Sorry about the noise.
That's okay.
Yeah, it's an airport. And quite a busy one with that. So thank you very much. Thanks to my crew for helping today. Jeff, thank you. Brenda, Stuart, thank you. It was a successful day. Thanks to all of you for making it so great. And hopefully see you at some of the meetings with you.
Yes.